Monday for this week, a worker earns $18 an hour. If pay increases to $21 an hour, what is the percent raise? To figure that out, we're going to subtract the new amount from the old amount, and that's a $3 difference. Now to calculate the percent of raise that was, I'm going to put that $3 over my original amount. So at first we made $18. So I'm going to divide that and then multiply it by 100. When I do that, I get 16.6 repeating percent. So approximately 16% raise is how we do that. This one was all about the shapes of distribution. So we looked at this one and we said, which three go together? Why do they go together? And there's multiple different ways you could group these. You could say that A, B, and D go together because they all have some sort of shape rather than a uniform shape that's all the same. You could say that A, C, and B go together because they're more symmetrical. If I put a line down the center, it's kind of symmetrical on both sides, where D is more skewed to the right. Yeah, there's just a couple different ways we could group those. This one, I gave them some cards to match, so you can just skip that one since you weren't in class. And then same with this one, I gave some matched ones and they had to guess what kind of question maybe produced that data. So you can skip this slide too. This one, the distribution shows the length of inches of fish caught from and released from a nearby lake. Describe the shape. We would say it's bimodal because there's two kind of sets there. So that bi means two. And then it's almost symmetrical too. If I put a line down the middle, it's almost the same on both sides, maybe a little bit skewed this way. Make an educated guess what could cause the distribution to have this shape. They might have talked about how, since it's talking about length of fish, maybe there's two different types of fish in that lake, and that's why you kind of have two sets of data points there. We can describe the data. This is just kind of notes from here on out. We can describe the shape of distributions as symmetric, skewed, bell-shaped, bimodal, or uniform. The dot plot and histogram shown here represent the distribution of the same data set. You can see how it's symmetric. Even the box plot down here kind of shows symmetric because it's pretty much in the middle there. Symmetric mean the mean is equal to the median, and there's a vertical line of symmetry in the center of the data display. Yeah, you can kind of go ahead and read these descriptions and keep them as notes. A bell-shaped distribution is a dot plot that takes the form of the bell, with the most of the data centered or clustered near the center, with fewer points farther from the center. So if you look here, like, yeah, most of the center is here, or most of the points are here in the center, not as much on either side. So that's kind of that bell shape, but it's also symmetric in this case. These ones have like a skewed distribution because it kind of goes off to one side. These are all kind of left skewed. If it were right skewed, it'd be on the, oh my goodness. If it was right skewed, it'd be going like this way instead of this way. It's skewed towards the left. In a skewed distribution, one side has more values than the other. So again, this side has more values than this one. So you can see it really clearly on the dot plot. There's more dots on this side than on this side. So yeah, that's skewed. Again, you can kind of read these to get more information. Uniform distribution means that the values are evenly distributed throughout the range of the data. It looks more like a rectangle. It's the same exact amount of data spots all the way across, 2 dots for every single number. And you can tell like the box plot just kind of looks very like, I don't know, perfect. So it's kind of a uniform look to it. That means the mean is equal to the median because a uniform distribution also has symmetric distribution. The box plot does not provide enough information. Again, like we can look at it and be like, it's perfect, but we don't know exactly, whereas these ones have the exact same level and these have the exact same amount of dots for every value. It's easier to tell. But it does suggest that the distribution may be symmetric. A bimodal has two very common data values, like where it's got here and here. It's kind of like two little humps, bimodal, just like we talked about with this one. This one would be bimodal because there's a clump here and a clump here. Yeah, it can be kind of distinct peaks. Sometimes a bimodal distribution has most of the data clustered in the middle. In these cases, the center of distribution does not describe the data very well, but they're not always symmetric. For example, the peaks might not be equally spaced from the middle of the distribution, and other data values may interrupt it. So like this one would technically be bimodal, but it's not symmetric. They don't look the same. This one would give us a symmetric. It's like cut down the middle, the exact same on both sides. This one would be skewed to the left because most of the data points are over here. And then this bottom one would be uniform. And again, this one is kind of that bimodal. So the exit ticket, which of these distribution is most likely to show data collected while studying the number of plates people use while eating in an all-you-can-eat buffet? I would probably say that this one is, because most people are going to use kind of 1 to 4 plates, and then it's rare that someone's going to go back 9 times to get more food, which is why this one would not make sense at all. This one also, like, some people don't eat as much, so they're going to use these kind of lower value plates, and then this bottom one just doesn't fit either. There's no way that it's a uniform scenario. And then they did the practice problems.